Okay, in this exercise we will determine the electron and molecular geometry of the following molecules. So before determining the geometry of a molecule, the first thing we need to do is make sure that we have the correct Lewis structure. So if we check the Lewis structure of the first molecule, we should notice that the oxygen is supposed to have two lone pairs of electrons. And this can be found in this table right here. You can see that the oxygen likes to have two bonds, and there it has two lone pairs of electrons. In that case, it has no charge. So here two lone pairs, and if you write down here number of the lone pairs, we'll have two. The next thing is the steric number. Steric number is the summary of the lone pairs and the number of the atoms that are connected to the atom that we are interested in. Here on the side we have CH3, and here this is a CH2, so there are two carbons connected to this oxygen. And if we want to determine the steric number, we need to add the number of the atoms and the lone pairs. In this case we have two atoms, two lone pairs, and the steric number is 4. Therefore the electron geometry for steric number 4, if you look here in this table from the summary sheets, we can see that this is a tetrahedral geometry, and you can write down here, so this is tetrahedral. But now as far as the molecular geometry, we have to ignore the lone pairs of electrons and name it as the molecule looks without electrons. So in this case, we're going to this case scenario where we have two atoms connected, and this is a band geometry. So this will be band. And the bond angle, ideally the tetrahedral geometry has a 109.5 angle. But here, because we have two lone pairs, there's a little deviation from this ideal angle. And in fact, it's about 104.5. And the hybridization of the oxygen is determined based on the steric number. Again, the steric number is 4, and that corresponds to sp3 hybridization. Okay, let's go to the next molecule. So here, on the periphery of the bond line representations, we need to remember that we have CH3. Or generally, we need to remember that a carbon has as many hydrogens as needed in order for it to have 4 bonds. Now, carbon does not have any lone pairs because it already satisfies the octet, don't have any lone pairs. So we can write down here 0 for number of the lone pairs, which we can also see here. If the carbon has 4 bonds, then there are no lone pairs here. Next is the steric number. So we have 4 bonds. There's this carbon that is connected to the carbon that we're interested in, and 3 hydrogens. So steric number is again 4, which again corresponds to tetrahedral geometry electronically. And in this case, it is tetrahedral for the molecular geometry as well, because it has 4 bonds connected and no lone pairs. So this will be tetrahedral as well, and here the angle will be the ideal angle of a tetrahedral. So this will be 109.5. And again, the hybridization in this case as well is sp3.